Okay, so we are going to do the opener today. It doesn't say opener, but solve these equations just to the right here. And you should find that something odd is going to happen. Okay, so do your best to start solving each of these. I will work them out as well, and then we'll get to the place where something odd happens, and we'll talk about what we need to conclude from that. But for now, go ahead and solve those first two problems, A and B. As you all work to simplify both sides, you should have found that something weird happens in both of these equations. Hey, in part A, after I distribute, I get 6x plus 3, and then we have minus 6x plus 4. So I started by combining the number portion. 3 and 4 is 7. But then I have 6x minus 6x, and all those x's go away. And so now there's nothing left to solve for, right? We are always ending an equation with x equaling something. Well, if the x's eliminate, that's going to tell us that something new is happening to our equation. Okay, so if I get down where all the x's eliminate, and we are left with something that does not make any sense, like 7 equals 9, we're going to consider that a false statement, right? 7 does not equal 9. And thus the conclusion is that there's no solution to this. And we haven't seen any equations that have no solution when involving the linear, okay, if it's linear. And so what this means is there's no value of x that we can plug in to get both sides to be equal. Okay, so literally no value of x that we can plug in to make this equation work. So then the contrast to that, or the opposite, okay, is here in part B, where if I distribute, and once again those x's eliminate, well, now when they eliminate, I'm left with 9 equals 9. That's a true statement. Okay, and if we eliminate the variables and are left with a true statement, it's going to be the opposite conclusion. And instead of it being no solution, now there's infinite solutions. Okay, meaning, I guess we could even say all solutions might be more appropriate here, but any number that we plug in, you know what, it is all solutions. Let's change that. Hey, any number that we plug into this equation will always give us something that works. So every number of x is going to make this equation work. Hey, and basically, if we were to graph it, what these are telling us is the false would mean that we could, and there's not a good place to graph it. That's kind of why these are a little bit tricky and why we do this whole lesson in itself. But basically, all the terms with x's, we're going to find, yeah, there's not a good representation for the graph here. We need variables on both sides for that to kind of make sense. So let's forget the graphs for now. Okay, so basically what we need to start paying attention to, and what's new about this lesson today, is that we can get no solution infinite, or excuse me, all solutions with every function now. So this is kind of our conclusion for the types of solutions. So linear, of course, we can get one solution. We've seen that a bunch of times. Okay, with quadratic equations, we've seen a lot that have two solutions. We've seen plenty that have no solution. We've seen some that have one solution. And same idea with absolute value. We've seen plenty with two, plenty with no, and plenty with one solution. And now what's new is that for all of these functions, so regardless of if it's linear, quadratic, or absolute value, we can get no solution if the variables eliminate and we get a false statement, like 0 equals 4, negative 3 equals 6. We could also get infinitely many solutions. All right, we'll stick with infinitely many. If the variables eliminate and we get a true statement, like 0 equals 0 or negative 5 equals negative 5. Okay, so if those variables disappear, we are thinking either no or infinite solutions, and it all depends on if it's a true or false statement. Okay, I'm going to skip 1 and 2. So go ahead and flip this page over. Again, we'll maybe do like 3 problems here. We don't need to do too many because all the solving is the exact same. And so let's do 3 and 4 here, and then we'll find at least one more for you all to do, maybe 2 more. Okay, so from what we did yesterday, our starting point is the exact same in that we need to simplify either one side of the equation or both sides. So on this left side, I'm seeing I have x squareds, and I can combine those. Well, if I have 6x squared and I take away 6x squared, those eliminate. So the x squareds are gone. And so I'm already anticipating this either being no solution or infinitely many solutions. So now I need to combine the number part. Negative 16 plus 4 is negative 12. And the right side is also negative 12. So because the variable eliminated, and I have negative 12 equals negative 12, which is a true statement, we conclude that this is infinite solutions. And thus, every value of x would make this equation true. All right, let's do one more here with number 4. Yeah, Kira, go ahead. I'll accept either one. Yeah, I'll accept either one. Infinite solutions or all solutions. Yeah, if you know the infinity sign is like a sideways 8. So that's another way to say infinite solutions. You can for sure draw that infinity sign. Okay. Number 4, I'm noticing a couple sets of parentheses, and so I'm going to have a little bit of distribution. And so that's always our place to start. By distributing 6 times 3, I get 18, and then that's times the absolute value of x. Then 6 times 3 again is 18. Then I have 9 times 2 to get a positive 18 absolute values of x. 9 times 2 to get 18, and it equals 18. Holy cow. 18 overload. Now let's go ahead and combine everything. So the absolute values of x, 18 plus 18 is 36 absolute values of x. And then the number part, 18 plus 18, is also 36, and it equals 18. So as of now, we don't have anything on our radar as either being no solution or infinitely many solutions. This looks just like a problem that we solved yesterday. So we could draw a graph. We could also jump straight into the solving where I need to go in the reverse order of operations. So dealing with any subtraction or addition first, I'm going to subtract this 36. And so I get 36 absolute values of x equals negative 18. And then this is 36 times that absolute value, so I need to divide by 36. And I get the absolute value of x equals, that's not going to be a whole number. If you try in your calculator, you can get it as a decimal, where it should say negative 0.5. And one thing we've talked about with absolute values is that it cannot equal a negative. So we're getting to no solution, but in a very different way here. Okay, the variable didn't eliminate it, but now we're just left off with knowing that absolute values can equal a negative. And so this is actually another no solution. Okay. Well, let's do this. Let's have you all solve. Let's do 7 and 8. The 2 problems right below this. Okay, it'll be the last 2 problems we do. I'll come around with homework shortly after. Right now, all I need is for you to try 7 and 8. They don't need to be perfect. See what you can do. We should have found that both variables eliminate here. Okay, in both 7 and 8. So the one thing that you need to be careful of with number 7, and I talked about this yesterday, the first thing that we're distributing is the positive 3, but the second thing we distribute, this is distributing as a negative 4. Okay, and it's really common for students to distribute it as a positive. Okay, but we have to pay attention to the sign on the left there. Otherwise, you'll get a completely different answer that seems to make perfect sense. Okay, so after distributing, the absolute values of x's eliminate. And now I'm left with 26 equals 14, which is false. Since it's false, we conclude that is no solution. So the answer is not false. If you stop and just say false, okay, you haven't actually answered what the solution is. And that's the fact that there isn't one. Okay, so you need to say no solution. Then on number 8, I'm distributing a negative 2 to the first set of parentheses and a positive 10 to the second set of parentheses. Once again, the variables eliminate, and I get negative 42 equals negative 42, which is a true statement, and thus we conclude that there's infinitely many solutions.